The alkyl cyanide, when hydrolyzed to the corresponding acid, the gas evolved is A. Nitrogen, B. Oxygen, C. Ammonia, D. Carbon dioxide. Alkyl cyanide, that is RCN, reacts with water, that is hydrolysis, gives acid plus ammonia. So the gas evolved is ammonia. Option C is the correct answer. Aniline, when treated with HNO2, that is nitrous acid, and HCl at 0 degrees Celsius gives A. Phenol, B. Nitrobenzene, C. A diazo compound, D. None of this. So when aniline reacts with HNO2 plus HCl, diazotization takes place at 0 degrees Celsius to give benzene diazonium chloride. The structure of benzene diazonium chloride is benzene attached to N triple bond NCl plus H2O. So benzene attached to nitrogen, double bond NCl. So option C is the correct answer. Aniline is treated with bromine water to give an organic compound X, which when treated with NaNO2 and HCl at 0 degree gives a water soluble compound Y. The compound Y on treatment with cuprous chloride Cu2, Cl2 and HCl gives a compound Z. Option A, orthobromochlorobenzene, B, parabromochlorobenzene, C, 2,4,6 tribromophenol, D, 2,4,6 trichlorobenzene, E, 2,4-dibromophenol. So when aniline NH2 reacts with bromine water, it gives X. So X is 2,4,6 aniline. So you have bromine at para and ortho. So which on reaction with NaNO2 and HCl gives a compound Y. So diazo salt, benzene with N2Cl, bromine is unaffected, so this is Y, which on reaction with cuprous chloride HCl gives 2,4,6 tribromochlorobenzene. So chlorine, bromine, this is Z, 2,4,6 tribromochlorobenzene. So option D is the correct answer. What is obtained when nitrobenzene is treated sequentially with ammonium chloride, zinc dust and H2SO4 in presence of Na2Cr2O7? A. Metachlorobenzene, B. Parachloronitrobenzene, C. Nitrosobenzene, D. Benzene. So when nitrobenzene plus hydrogen in presence of Zn NH4Cl will give phenyl hydroxylamine. Hydroxylamine on warming with any oxidizing agent is easily oxidized back to the corresponding nitroso compound. So this is phenyl hydroxylamine on reaction with H2SO4 in presence of Na2Cr2O7 and oxygen will give nitrosobenzene. So option C is the correct answer. Identify the product C in the series. So when nitrobenzene reacts with FeCl to form A, which is aniline, which on reaction with nitrous acid at 0 degrees Celsius will give diazo salt, which is B, which on hydrolysis will give phenol, which is C. So option A is the correct answer. Chemical reaction, aniline in presence of NaNO2 and HCl gives A and HBF4 gives B. The compound A and B respectively. A. Nitrobenzene and chlorobenzene, B. Nitrobenzene and fluorobenzene, C. Phenol and benzene, D. Benzene diazonium chloride and fluorobenzene. So reaction of aniline in presence of NaNO2 and HCl, which form nitrous acid HNO2 at 0 degrees Celsius, to give diazochloride, which on reaction, so this is A, so benzene diazochloride on reaction with HbF4 will give fluorobenzene. So option D is the correct answer. Amine that cannot be prepared by Gabriel thalmide synthesis is A. aniline, B. benzylamine, C. methylamine, D. isobutylamine, E. tertiary butylamine. Only pure primary amines can be prepared by Gabriel thalmide synthesis. Aniline cannot be prepared by this method because aryl halides, that is C6H5Cl or Br, do not undergo nucleophilic substitution reaction. That is cleavage of CX bond in haloarine is quite difficult with potassium thalmide under ordinary condition to give N-phenylthalmide. So option A is the correct answer. Which of the following is most basic towards BCH3 thrice? It is easier to remove a proton from 4-methylpyridine. An electron left behind when the proton is removed is delocalized onto electronegative nitrogen atom. In 2-methylpyridine, electron can delocalized only onto carbon atom. So option A is the correct answer for 4-methylpyridine. An organic compound A on treatment with ammonia gives B, which on heating gives C. C when treated with bromine in presence of KOH produces ethylamine compound A is. So when propionic acid, that is CH3CH2COOH, on reaction with ammonia will give CH3CH2COONH4, which is B. On heating gives CH3CH2COONH2 compound C, which on reaction with potassium hydroxide and bromine, that is Hoffman bromamide reaction, it will give ethylamine. Here decarboxylation takes place. So option B is the correct answer. Primary, secondary and tertiary amine can be distinguished by A. Schiff's test, B. Fehling test, C. Tollens, D. Heisenberg test. A mixture of primary, secondary and tertiary amine can be distinguished by Heisenberg's test. Or Hoffman's method. In Heisenberg method, benzene sulfonyl chloride, that is C6H5SO2Cl, this is known as Heisenberg reagent, is used. Primary and secondary amine reacts to give sulfonamide derivative with loss of HCl, whereas tertiary amine do not give any isolable product other than the starting amine. In the later, so quaternary ammonium salt may be formed as an intermediate, but this rapidly breaks down into water to liberate the original tertiary amine. So option D is the correct answer. If nitrogen and sulfur are present in an organic compound during Lessing's test, then both changes into A. Na2S and NaCN, B. NaSCN, C. Na2SO3 and NaCN, D. Na2S and NaCNO. So when sulfur and nitrogen both are present in an organic compound during Lessing's test, both changes into sodium thiocyanate, that is NaSCN, which gives a blood red coloration with ferric ion. It can be detected by NaCNS plus FeCl3 ferric chloride will give ferric sulfocyanide FeCNS thrice plus 3 NaCl. So red coloration is formed. Option B is the correct answer. RNH2 reacts with C6H5SO2Cl in aqueous QH to give a clear solution. On acidification, a precipitate is obtained, which is due to the formation of. So when benzene sulfonyl chloride, that is C6H5SO2Cl plus RNH2 gives RNHSO2C6H5, which on reaction with KOH gives RNKSO2C6H5. This is soluble in potassium hydroxide. So option C is the correct answer. Melting point are normally the highest for A. tertiary amide, B. secondary amide, C. primary amide, D. amines. So the higher the boiling point of amide is because of intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding, they have high boiling point. Then amine, and amongst the amide, other boiling point are primary, secondary and tertiary. So they have higher boiling point than amines. This is because of alkyl group by which the carbonyl oxygen do not form the hydrogen bond. So primary amide have high boiling point and tertiary amide does not have to form the bond with oxygen of the other amide and have least boiling point. So option C is the correct answer. C3H513 reacts with HNO2 to give optically active alcohol. The compound is A. pentane 1-amine, B. pentane 2-amine, C. N-common dimethyl propane 2-amine, D. N-methyl butane 2-amine. HNO2 reacts to give an alcohol means that compound is primary amine. So C5H13N is thus C5H11NH2. Optically active alcohol means C5H11 segment contains a chiral carbon. So the structure will be HCH3. So this carbon is chiral carbon. Option B is the correct answer. When benzylamine reacts with NaNO2 and HCl, give X, which on further reaction gives Y and Z. So we have to find what is Z. So when benzylamine reacts with NaNO2 and HCl, there is formation of benzene diazonium chloride, which on reaction with Cu2CN2 will give benzene cyanide or nitrile, which on further reaction with water, hydrolysis takes place to form benzoic acid. So C6H5COOH is Z. So option B is the correct answer. In the reaction of methyl cyanide with hydrogen in presence of HCl and ether gives X, which on boiling with water gives Y. So we have to find what is Y in this reaction. So when methyl cyanide reacts with hydrogen, 2 hydrogen in HCl and ether, it gives acetylene, which on boiling in water will give acetaldehyde. So option C is the correct answer. The strongest base is. According to Lewis, a base is a species that can donate a pair of electrons to form a coordinate bond with an acid. So a secondary amine it has lone pair of electron in sp3 hybridized orbital, which can easily be donated. Therefore, it is the strongest base. So option A is the correct answer. Which one of the following is the strongest base in an aqueous solution? A. Trimethylamine, B. Aniline, C. Dimethylamine, D. Methylamine. In aqueous solution, basic order is primary, secondary, and tertiary amine. And with methyl group is secondary, primary, and tertiary. In case of aniline, lone pair of nitrogen is involved in resonance, so it is weaker base than aliphatic amine. So dimethylamine is the correct answer. The following compound can be classified as N-dimethyl propanamine, N-methylamine, and aniline. So because N-dimethyl propanamine is tertiary amine, so N-methylamine N-methyl aniline will give secondary amine, which is NHCH3, and aniline will give primary amine. So option E is the correct answer. The end product in the following sequence of reaction is. So when this compound reacts with lithium aluminum hydride, the structure formed is NH bound to CH2OH, which on reaction with PCl5 there will be replacement of hydroxyl group with chloride. So the structure will be CH2Cl, which on reaction with NaCN there will be replacement of chloride with Cn. So the structure formed will be which on reaction with H3O plus then formation of acid So option C is the correct answer. The major product, that is 70 to 80% of the reaction between meta-dinitrobenzene with NH4HS is. So when meta-dinitrobenzene reacts with NH4HS, there will be formation of 3-nitro aniline. There will be reduction of 1 nitro compound. So option B is the correct answer. Starting from propanoic acid, the following reaction carried out is. So when propanoic acid when react with SOCl2 will give CH3, CH2, COCl, acyl chloride plus SO2 and HCl. So when COCl reacts with ammonia, it will give CH3, CH2, CONH2, acidamide plus HCl, which on reaction with bromine in presence of base NaOH will give ethylamine plus carbon dioxide. So Z in the following reaction is ethylamine, option B. In the following, X is X on brominating. So here gives Y, which on reaction with NaNO2 and HCl gives Z, which on boiling in presence of ethyl alcohol give tribromobenzene. So when aniline is brominated, it gives 2,4,6 tribromo aniline, which on further reaction with NaNO2 and HCl will give diazo tribromoaniline benzene, which on boiling with ethyl alcohol give tribromobenzene. So option D is the correct answer. Methane plus HNO3 on heating gives. So ethane undergoes nitration to give nitroethane and nitromethane. So option B is the correct answer. Nitrobenzene combines with hydrogen in presence of platinum to produce A toluene, B benzene, C aniline, D azobenzene. So nitrobenzene on reaction with hydrogen in presence of platinum as catalyst will give aniline plus water molecule. So option C is the correct answer. When chlorobenzene is treated with ammonia in presence of cuprous oxide in xylene at 570 Kelvin, the product obtained is A benzylamine, B diazonium salt, C Schiff's base, D aniline. So when chlorobenzene react with ammonia in presence of cuprous oxide in xylene will give aniline plus cuprous chloride plus water. So option D is the correct answer. For the preparation of para-nitroiodobenzene from para-nitroaniline, the best method is A. NaNO2 in HCl followed by Ki, B. NaNO2 HCl followed by CuCN, B. Lithium aluminium hydride followed by iodine, D. NaBH4 followed by iodine. So para-nitrobenzene from para-nitroaniline can be obtained when para-nitroaniline in NaNO2 and HCl will give diazobenzene, which on reaction with Ki will give para-nitroiodobenzene. So option A is the correct answer. Acid medium nitrobenzene is reduced to aniline as shown in the reaction. The reducing agent used in this reaction is, so in this reaction it is example of Stephen's reaction, which the reduction of nitrobenzene takes place in presence of catalase, that is Sn plus HCl. So option B is the correct answer. It helps in strong reduction to form benzylamine, aniline. Aniline is produced in presence of Fe and HCl from preparation of aniline from nitrobenzene in FeHCl. The mechanism is ion with HCl give FeCl2 plus 6 hydrogen, C6H5NO2 with hydrogen will give aniline, FeCl2 with water will give ferrous hydroxide, and nitrobenzene with ferrous hydroxide and water will give aniline plus FeOH thrice, ferric hydroxide. So nitrobenzene is aniline is prepared in presence of FeHCl from nitrobenzene. Option B is the correct answer. A series of reaction aniline in presence of diazo salt Na2HCl gives X, and in reaction with nitrous acid give Y. So X and Y are. So when alanine reacts with NaNH2 and HCl will give diazo salt of benzene, which on reaction with nitrous acid will give nitrobenzene plus nitrogen and HCl. So option C is the correct answer.